All right, so heading back over to the slides here, we have this thing called dot notation. And I need you to make sure that you really get this dot notation figured out because it's very important for programming. You're going to use it in Java, you're going to use it in Python, you're going to use it in JavaScript, you're going to use it in C. Dot notation essentially is a way to call a function belonging to a module. Okay, so if I imagine I have this group of folders, and inside of the folders are a bunch of papers. And in these papers are a bunch of functions or formulas. Okay? The way I have to have some sort of a way to get to the function that I want. So let's say the folder name is physics. Okay? So I'm going to call it physics. Let's say the sheet that I want to use is kinematics. And let's say the function I want to use is velocity. Okay? Or actually, let's do something better than that. Let's do kinetic energy. Okay, so in dot notation, the way that I would do that is I would have physics, which is the folder, dot kinematics, which is the page, dot kinetic energy, which is the formula. Okay, so each time I go down a little bit further, I do a dot. I do a dot notation. Okay, so in general, we don't often go down that far in a Python in a sort of a normal Python script because the standard library doesn't usually go that deep. So usually it's going to be module name dot function name. Okay, so we've imported random, obviously. Random is the module name. We called it RD. Okay, so now it's RD is the way we reference it. So now in order to access something inside that module, I have to use dot notation. Okay, so I can do RD dot something. Okay? And you can actually see how PyCharm is really helpful, and it actually tells you some stuff that you can actually use from that. What we're going to be using is randint. Okay, so I can type randint, I can choose it, and then hit enter. Okay, now that it's a function, obviously I have to put parentheses on that. Okay, so again, that's the way that dot notation works. I'm reaching into RD because we called random RD, and I'm using the function from RD called randint, which is random integer. So, talking about that randint function, essentially what that randint function does is it generates a random number in the range provided by the arguments. Okay, so it returns the random number to a part of the program that called the function. The returned integer can be used anywhere, and you can sort of experiment with it in interactive mode. So let's just, because you're going to be experiencing this a lot, let's just go ahead and experiment what we have here. And then I'm actually going to show you how you can maybe even use the internet to look up how you can call some of these sorts of things. So right now I have rd.randint. If I call this, it's going to work, but it's not going to print anything. And I want you to sort of think about why. So let's go ahead and run this. And actually it's mad because it's missing an integer, right? It needs A and B, right? Okay, so obviously it needs something to go inside of this. It says random.randint missing 2 required positional arguments. Okay, so the randint function actually needs something, but I'm not really sure what that is. So one thing that you can do is you can actually go to Google or anything like that, and you can just type in the module and the function name, and you can actually just look that right up. There's like W3 Schools, stuff like that. Okay, and it'll actually kind of help you to understand, okay, here's random, here's randint, here's an example. I'm going to do random.randint 39, and then it's going to actually tell you what those parameter values are. Okay, so we know what a parameter is. Okay, it's this definition in the function header. Okay, so apparently we have a start and a stop. So start is required. It's an integer specifying which position to start, and stop is an integer for which position to end. Okay, so obviously this told us that we called it wrong, right? Because we missed 2 arguments, A and B. See how it says missing 2 required positional arguments. Okay, so let's just play around with that. So I guess we can start at 5, and maybe we can go to 10. How about that? So there is randint 5 to 10. So that should generate some random integer from 5 to 10. But again, it's not going to do anything, is it? Right? Why didn't it do anything? Well, first off, it did something. It actually did generate a random integer from 5 to 10. It just didn't save it anywhere or didn't do anything with it. Okay, so the easiest way that we can make that show up is just by putting it into a print statement. Just like such. All right? So I have now generated a random number of 10, 9, 8, 7, 7, 7, 8, 10, 9, 8. Okay, so to show the variability, let's go all the way up to 1,000. Okay, 158, 280, 639, 552, 302, 315, so on and so forth. Okay, to generate how it can do that, we can actually just make a nice little for loop, right? For x in range of, let's say, we want to generate 1,000 random numbers. Okay, so we're just going to go ahead and loop 1,000 times. We're going to generate 1,000 numbers, and we're going to print those out. So there you go. I have 1,000 numbers. Now, if I wanted to put those all on one line and make it real hectic looking, I could actually do an end of line as nothing, right? Or maybe I can put a comma in between them. So there you go. Now I'd printed them out in one ginormous line there. Okay? So that's the way that that works. That's rand.randint. And again, this is start, that's end. Now, obviously, we know that we can actually take user input, right? So we can actually make these user defined if we want to. So I can ask the user for the number of random integers to generate. I can ask the user from where to what, so from what to what, right? So I can have them put in the range, and then I can have it generate numbers for them. Okay, so that's really, really powerful whenever you're interacting with your users. Okay, so that's sort of the way that that randint works. We have the two arguments that go in, the start and the finish, and then there is the function call. Now, this is referring to random because they just did it without doing this as RD. Okay. So again, this is the way it works. It's just some random number that actually comes out into this variable, or it goes out through the print statement, which is what I already showed you. All right, so again, we have some other functions inside of this module. Randint isn't the only thing that is available to us. Obviously, whenever I used the dot notation, it brought up a lot of stuff. So I have randint, I have random, I have, random bytes, I have random range, I have shuffle, I have all kinds of different functions that are available inside of that random. I have get state, I have get, tr and bits. I don't even know what that is. It's got all kinds of really interesting random number sorts of functionality. Okay, so a few of them that are really, really important to us that we're probably going to use throughout the semester. We have this rand range, so it's just like range, but it generates a random range. We have the random function, so it's just like rand int, but it generates floats. And then we have the uniform function, which returns a random float, but allows you to specify the range. Okay, so essentially we have these other functions that we can mess around with. So let's go ahead and do the rand range, and let's just play with it a little bit. So I have rand range. All right, so we're going to see what happens whenever I print that rand range. And it said it's missing a positional argument, which is start. So we want to go ahead and start that at 5. Boom. We have the range as it's going down each time it's adding. And what's interesting is, so it's within that range. So it's somewhere inside of that range that it's actually creating it. Okay. So it's similar to the range function, but it returns randomly selected integer from the resulting sequence. Okay. So 1 to 5, so 0 to 4. So 0, 1, 2, 0, 0, 1, 1, some number from 0 to 4. Or I could do some number from 0 to 499 as well. So there you go. Okay, so that's the rand range. It's a lot like randint, but sometimes it can be useful. We also have just random, rd.random. And rd.random apparently doesn't have any input, right? Because it just says 0 to 1. Just returns a float from 0 to 1. So let's go ahead and see if that works. Look at that. From 0 to 1, we have 0.65, 0.20, 0.00, so on and so forth. Okay, but then you can also use the uniform, which is rd.uniform. But you can actually do the range. So you can actually give it something like from 5 to 120. So there you go. So now I'm actually generating floats that actually have a range. Okay, so these are the ones that we're oftentimes going to be using as we're sort of doing our coding throughout the semester. Now, there is one thing about random that we all need to understand. And I tell my students this all the time, and it's important that you remember this. Computers cannot generate actual random numbers. It is absolutely impossible. Now, sometimes we can use hardware variations, variations in voltage, static temperature, humidity, different impedances in the circuits, stuff like that, to do some sort of a combinatoric value that helps us to generate something that's more random. But in general, random numbers on a computer are never truly random. In fact, what they are is what we would call pseudo-random. So it uses some algorithm to generate some number in some way that appears to be random but is not. So the random number created by functions in random are actually pseudo-random. Now, the way that these work is they use something called a seed value. So it initializes the formula that generates the random numbers, and you have to use different seeds in order to get different series of random numbers. If you use the same seed, you'll actually get the same random number. Okay, so if you use the same seed for your random module, you will always get the same series of random numbers. So the question is, what do we use as a seed, right? What is always changing? What is never different? Or what is never the same, sorry. What is always changing? What is never the same? Well, most programmers agree that time moves forward and does not move backwards, and the system clock always moves forward and never moves backwards, so we should never, ever have a repeated value in the system clock, at least in our lifetimes or for 1 trillion years. So by default, the way that these computers seed their random numbers is using system time. Okay, but you can also set the random seed if you would like to. So you can use the .seed function to specify a desired value. So to show you how this sort of works, I'm actually just going to go ahead and set the seed so that you can see that I generate the exact same series of numbers every single time. So we're going to go from, let's go from 0 to 50. And let's go ahead and set our rd.seed. Let's set it to 10. Okay, so every single time that this goes around, it should generate the same number over and over and over again. Okay, you see that? I generated 36 a boatload of times, right? Because I set the seed to 10 and it starts at 36. Okay, now I can make it appear different if I put the seed outside, right? Because I'm not resetting the seed each time. So now it should generate a random series of numbers that appear to be random. But they're not actually random because if I go back to the top, oh, and actually I don't want to go that many loops. Let's just do 10. Okay, so here's 10, 36, 2, 27, 30. So it appears random, good. But since I keep setting the seed to 10 every time I run it, notice that it generates the exact same output each time. If I go to 11, it's going to generate a different output. Okay, but then if I go again, it's going to generate it over and over again. Okay, so if you don't set the seed, it sets it to system time so that it always appears that the values are random. Okay, but if you ever need to set that seed, you can set that seed just by using the rd.seed. But you need to set that seed before you actually use random, the actual functions inside of it. And again, you can actually reset the seed to something else if you want to. So I can set the seed and then I can do another random call and then I can set the seed and do another random call, so on and so forth. So I would just encourage you to go ahead and experiment with the potentialities that you have there. All right, so we're going to take a little break. We're going to come back. We're nearing the end here. I appreciate your patience. This is extremely important. So please, drink your coffee, do whatever it takes. Make sure you're following along on PyCharm because this stuff is extremely valuable for the rest of the semester. So I really, really, really want you to be paying attention and following along. All right, so we'll see you on the other side in a different video.